Let us solve this third problem. The problem is given as we have to find the maxima and minima of this particular function. The function is given as y is equal to x cube plus 6x square minus 15x plus 5. So first step will be to find dy by dx and second order derivative d2y by dx square. So let us begin with dy by dx. Differentiate with respect to x. Derivative of x cube will be 3x square plus 6 is constant. Derivative of x square is 2x minus 15 is constant, and derivative of x is 1, plus derivative of constant term alone is 0. So this comes out to be 3x square plus 12x minus 15. Now again differentiate with respect to x, we get d2y by dx square, the second order derivative. Here 3 is constant, derivative of x square is 2x plus 12 is constant, derivative of x is 1 minus derivative of constant alone is always 0. So it comes out to be 6x plus 12. So we have completed the first step, finding the two derivatives. Now the second step is to find the value of x. To find x is equal to a and b. These are the two values of x where dy by dx is equal to 0, means the slope of tangent to the curve at these points is 0. So put dy by dx is equal to 0 in the equation of dy by dx. Here is the equation. So it will be 0 is equal to 3x square plus 12x minus 15. Now this is the quadratic equation. We have to solve 3x square plus 12x minus 15 is equal to 0. Now this equation can be solved in two ways. Let me explain you both of them. So you can choose any convenient, whichever is easier for you. So first is, let us divide by 3 each term. So it comes out to be x square plus 4x minus 5 is equal to 0, divided by 3. Here 3 has gone. This is 3 4s are 12, 3 5s are 15. And now here we split 5 such that the multiplication is minus 5, addition is plus 4. Since the sign needed here is plus, so we give plus to bigger number and minus to smaller number. Now see, the multiplication minus 5, if we add them it is plus 5. So it comes out to be x plus 5, x minus 1 is equal to 0. So x plus 5 is equal to 0, or x minus 1 is equal to 0. So x is minus 5 and x is 1. So these are the 2 points at which the slope of tangent to the curve is 0. For some students this is a bit difficult. For them there is easier method, that is a is equal to 3, b is equal to 12, c is equal to minus 15, and x is equal to, this is the formula for root of quadratic equation, minus b plus or minus under root b square minus 4ac upon 2a. So it will be minus 12 plus or minus under root b square 12 square minus 4a is 3 into c is minus 15 upon 2a, a is 3. So here minus 12 and in the denominator it is 6, plus or minus, let us calculate this term using the calculator. It will be under root 12 square minus to bracket 4 to 3 into minus 15, bracket complete, it comes out to be 18, so it will be plus or minus 18. Now here we make two values, x is equal to minus 12 plus 18 upon 6, this will be first value, first root, and x is equal to minus 12 minus 18 upon 6, so here it will be plus 6 upon 6, so x is equal to 1, and here x is equal to minus 30 upon 6, so x will be equal to minus 5. So we get the same values, see these values remain the same, but the method is different. You can choose anyone, whichever you find convenient. So we have completed the second step. Now we will go for the third step, that is check for maxima. The third step is to check where maximum occurs. Check for maxima means till now we have come to know that the function has slope of tangent 0 at both these points, but we don't know whether it is maximum at 1 or minus 5. So this is the check. The check is like this: d2 by dx square at, put any one value, x is equal to 1. Now d2 by dx square we have found 6x plus 12, so 6x is 1 plus 12, so it comes out to be 18, and 18 is a positive number, and if this comes out to be positive, it means that function is minimum at x is equal to 1, and obviously it will be maximum at x is equal to minus 5. And last step is to find these two values, find y max and y min. Y max, maximum value of function in that particular area, and y minimum. So y max will be x is equal to minus 5. Put in the equation of y, so equation of y is x cube. Let me write for this equation: x cube plus 6x square minus 15x plus 5. So putting minus 5 cube plus 6 into minus 5 square minus 15 into minus 5 plus 5. Let us find it into calculator. Into bracket minus 5 cube plus 6 into bracket minus 5 square minus 15 into bracket minus 5 and plus 5. This all comes out to be 105. So the value of y max, the maximum value of function y max, is 105. This is the maxima we have been asked to find. This is one answer. And y minimum, we have found that it occurs at x is equal to plus 1. So putting it here, 1 cube plus 6 into 1 square minus 15 into 1 plus 5. So it will be 1 plus 6 minus 15 plus 5. So 11, 12, it will be minus 3. So this is the minimum value, that we call it minima. So we have found maxima and minima of that function. Now let us verify graphically whether what we have done is correct or not. So this is the tool. Y is equal to, I have put, the website is desmos.com/calculator. So I have put this equation, y is equal to x cube plus 6x square minus 15x plus 5. The graph looks like this. This is the graph of that equation. Now here there are 2 points. This is the first point at which the tangent is, this is the tangent to the curve which is parallel to x-axis, and this is another point just below x-axis. So this is the maxima, this is the minima. So let us zoom it out. Zooming will give us, let us check what the point is. See, the point is -5 and answer is 105, and this is the maxima. X is equal to -5, the maxima occurs at, and value of maxima is 105. And let us go to minimum value. The minimum value is here. It occurs at x is equal to 1, and the value of minimum function of y is -3. So what we have done is exactly correct. Okay, you can check any graphs on this website. It's a very nice website. Thanks for watching.